Alright, so trig addition identities again, this time part 3. Now, example, find the exact value of sine pi on 8. Now, in a previous example, you've seen that when we do our addition identities, we can split this up into two exact values that we know in the past, that we know from our standard triangles, from our unit circle, and we can work from there. Now, you can muck around and experiment and try to come up with whatever you can, but pi on 8 is not going to do that. You can't split that into two numbers that work neatly. But you should see pi on 8 is a multiple of one of those things. So pi on 4. If I take pi on, not a multiple, a factor, sorry. If I take pi on 8 and multiply it by 2, that's going to equal 2 pi on 8, which is the same as pi on 4. So we're going to use this piece of information to be able to solve this along with some of our addition identities. Alright, now even though we're dealing with a exact value for sine pi on 8, if I use my cosine addition identity, I can manipulate this a little bit. So it's going to be 2 times something. So I'm going to use cos x plus x, or a plus a. Now, you've seen what happens when we do cos a plus a before. Now, if we use a here and a here, we end up with cos squared a. And if we use it here, we end up with negative sine squared a. So this is a natural movement from our cosine identity. Now, if I go one step further here, we can say that cos a plus a is going to be equal to, and I can, let's replace cos squared a. And we'll replace it with the Pythagorean identity, 1 minus sine squared a. So now I have 1 minus sine squared a minus sine squared a. And I can say that that's 1 minus sine squared a minus sine squared a is 2 sine squared a. Alright, so we've done a lot of work here to sort of create a new identity. We've said that cos x plus y, if the x and the y are the same, it'll be this, and we can finally get down to here. Now, why have I done that? Well, now we can use this information and this information along with this. So we can say that cos a plus a, let's use a different color, cos, now a plus a is going to be pi plus 4, is going to be pi on 8 times 2, which is just pi on 8 plus pi on 8. That's how we've got this multiple thing going on. Is going to be 1 minus 2 sine squared, just a, just one of them, pi on 8. Okay, so it feels like I've done a lot of magic here, but think about why we've done this. We want to find out what sine pi on 8 was, but we couldn't get pi on 8 directly into an addition identity on the left-hand side like we have in the past. So what we've been able to do is, by using the cosine identity, the opposite of the sine identity, we've got it down to such a stage that we say that cosine a plus a is equal to sine a, which is the thing, or sine squared a, which is the thing that we actually want. So now that we've done that, we just need to solve this entire thing. So we can say 2 times pi on 8 is pi on 4, equals 1 minus 2 sine squared pi on 8. Now that pi on 4 exact values is 1 on root 2. And then we just sort of solve that Move the 1, divide by a -2, square root, and we should get an answer. Just taking the square root of all of that, this gets really, really ugly. We can take the square root at the bottom, it just becomes 2. So we've got root 2 minus root 2 equals sine pi on 8. Now, you might be tempted to put a plus or minus out here, but remember we were asked to find the exact value of sine pi on 8. Now, that's going to be in quadrant 1. Pi on 8 is quite a small angle. C-A-S-T. So it's going to be a positive answer there. Alright, a lot of working there. There's a little bit of trickery up the top, but with these ones, if you're dealing with a multiple, you're going to have to use the opposite trig identity, the opposite addition identity to make it happen.